The learning objective for this video is understanding the physics of different branches of collisions, which are elastic and inelastic collisions. The definition of collision is a brief dynamic event consisting of close approach of two or more objects, such as two cars, resulting in an abrupt change of momentum or exchange of energy. Now let's go more in depth into collisions, branching off into elastic and inelastic collisions. An elastic collision, known as a sticky collision, is when two objects collide into one another and stick together in the outcome. Elastic collisions are defined as one in which there is no loss of kinetic energy in the collision. And in elastic collision is when two objects collide into each other and the objects bounce off each other and move in opposite directions. Inelastic collision can also be defined as one in which part of the kinetic energy is changed to some other form of energy in the collision. So the components are M, which is mass, V, which is velocity, and P, lowercase p, which stands for momentum. Now, in a situation of a car driving, the mass would be the weight of the car, so we're just going to make up a number like 605 kilograms. And the velocity, which is 58 meters per second. And then this all equals together momentum. Say Luis has a baseball bat, and the baseball bat weighs 10 kilograms. That's our mass. And one of his friends throws him a baseball, and he throws it at 600 meters per second. That's our velocity. We want to find the momentum. An equation for momentum is P equals M times V, which is momentum equals the mass times the velocity. So we plug in what we have, which is 10 kilograms multiplied by 600 meters per second, which turns out to be 6,000. So the units for momentum is kilograms meters per second. You can use this process to solving problems for collision. In this collision problem, I threw a 2 kilogram baseball at 10 meters per second to Andreas, who swung a 4 kilogram bat at 15 meters per second. To find the final velocity of the baseball, you use MVP tables to recreate the collision. For this particular collision, since it's an inelastic collision, it requires two MVP tables after the collision, which is represented by this little squiggly line. For the first two boxes, you need to plug in the corresponding measurements given in each object. Then find the momentum by using momentum equals mass times velocity. Then for the MVP tables after the collision, the masses would be the same because in an inelastic collision, mass is conserved. The bat's final velocity is 0 meters per second, therefore the momentum is 0 as well because of the equation P equals M times V. To find the final momentum for the baseball, subtract the bat's final momentum by its initial momentum, then you take that number and add that to the baseball's initial momentum to require the baseball's final momentum. Finally, to find the final velocity for the baseball, modify the equation P equals mv to V equals P divided by M. Then plug in the measurements. Bam! Boom! Done!
Thanks for watching. That's all, folks.